Now here in today's session, we'll be looking into the end-to-end implementation of a machine learning project. So we'll start with a very basic project. So when I say basic, so by going through this, you'll be able to understand how does a simple end-to-end deployment of a machine learning project would look like. So this is at a beginner level. Now, as we proceed in the learning journey, we'll also increase the complexity. And as the complexity goes on, we'll also talk about the advanced aspects of machine learning and the deep learning project deployment. So let's get started. I'll start by creating a new notebook. So here, for the demonstration purpose, I'm going to make use of a data set that's a very simple data set, that is the iris data set. So the task that we are going to do is the classification task. So the first things first, whenever we are working with any data science project, we would require the data. So as a good student, let's get started and let's load the data set from sklearn.datasets. I'll go ahead and I'll import the load iris data set. Okay, so this is the first thing that we would require as a data scientist, that is the data set itself. Now, once we import the data set, so we will then go ahead and separate the features and the target. So let me just load the data. Okay, I'll say iris is equal to load underscore iris. Then I'm going to say x is equal to iris.data and y is equal to iris.target. So this is going to load the data set from the scikit-learn library, and I'm going to separate my input as well as my output. If I display the shape of my x, this is how my x would look like. My x is having 4 inputs and y is having a single label. And the task that we are going to do, let's look into the task. So the task that we are going to do is a multi-class classification. Okay, that's the simple agenda that we have got. Now here I want to identify as to which class does that flower would belong to. Here in our iris data set, so we actually have 3 classes available. One is Setosa, and these 4 features that you observe in this data set. So these 4 features are, if I display the features name, they are sepal length, sepal width, petal width. These are the 4 features that we have got on this iris data set. Are you clear? So the task I want to do is, given these features, what will be the class it would belong to? Okay, that's the simple task that we are going to do. Now we have picked up a very simple data set because our main agenda is to implement a machine learning model. So as a next step, we'll start by loading the machine learning model. So I'm going to load a machine learning model. So this time I'm going to make use of decision tree algorithm. As you know, decision tree is a powerful algorithm, and more specifically, I'll be loading the decision tree classifier. And not just that, in any machine learning project, you'll not just use the data as it is, you're going to transform the data. To replicate this transformation, I'll also load a pre-processing. So from sklearn.preprocessing, so this will help me to show you the various aspects of the data science project. So normally we will have a data set, and once we get the data, we will then transform it. Now at this point of time, if I'm working with the big data, maybe as part of data engineering, I'll be performing the ETL activities. It could be extract, transform, load, or it could be as simple as applying the scaling on my given data set. So to help us replicate the same, at this point of time, I'm going to say from sklearn.preprocessing, I'm going to import standard scaler. Okay, I'm going to import this standard scaler. Now, once I've imported this, let's go ahead and apply the standard scaler on this data set and apply the decision tree classifier. So SS is equal to standard scaler. Now this is followed by performing the fit and transform on this data set. So let's do one more thing. Along with this, we'll also load the train test split function, which will help us to split the data set into 2 parts. So from sklearn.model_selection, I'm going to import train test split function. Okay, next here itself I'm going to split the data set. Okay, xtrain xtest ytrain and ytest is equal to train test split function, and inside the parentheses I'll specify x and y, and I'll mention my test size. Okay, and I'm going to mention my random state to ensure the repeatability. Okay, if I want, I can also specify the stratify if I want to create a stratified split. For now, I'm going to keep it as it is. Okay, so this will split my data set into two parts. Now, once I split my data set into two parts, here while performing this data set, okay, especially on my training data, we will perform the fit and transform on my xtrain. And as a general practice, when we want to perform the transformation on my test data, we will just directly perform the transformation on my test data. Now, the common question that I would generally get whenever a learner or a colleague would ask, at least the person who's beginner in a data science, is, hey Murthy, why do I apply fit and transform on my xtrain, and why do I just apply the transformation on the test data? So think about it. When I'm creating two splits, that means my xtrain and xtest, when I'm creating these kind of two splits on my data set, think of it in this way. This is the question and answer, that is your class notes, and this is your examination questions. So before the start of the curriculum itself, that is before the training would begin, you are separating your examination questions as well as your classroom notes. So as a result of this, whenever you are learning the patterns in the data set, you will use only the resources that is available to you. Now in this scenario, whatever the learning that I want to do, it is with the help of the data set. Now, the data set that I'm given with is my training data. So since I have just the training data, I'll just make use of my training data and apply the fit and transform on this training data. Now, whatever the learning that I'll have from my training data, I'm going to apply that learning on the new data. Now, in this scenario, it will be applicable on the test data. I'm not going to apply fit and transform on my xtrain and xtest as well. Okay, that's a wrong practice. Now, the reason that I'm showing you this, because normally when we are working with the real-time project, we want to treat it in this way. We will generally have large volumes of the data set. When we have large volumes of the data set, we want to set a data set as an evaluation data. Now, this will help us to evaluate the machine learning models. And even when we are deploying any machine learning model version to the production, we want to use this test data as an evaluation data or kind of a benchmark to measure as how well my new version of the model is performing compared to the older version. Okay, so later on we'll talk about all those aspects, that is the versioning and deployment. So for now, let's come back to our topic. We are now interested in continuing to build this basic algorithm. So we have performed the fit and transform on the training data and perform the transformation on my test data. Now, once this is done, we'll straight away go ahead and apply the machine learning algorithm. So I'm going to say tree is equal to decision tree classifier, and I'm going to apply my xtrain and ytrain. Okay, so this will perform the fit. Okay, so let me just correct it. Okay, I'm going to use the default parameters team. I'm going to initialize the decision tree object and I'll perform the fit. Okay, I'll perform the fit on my training data. Now, once the fit is done, so we'll just go ahead and perform the evaluation on the test data. So here I'll say tree dot score, and I'm going to apply the test data, that is xtest and ytest. So here on my test data, I'm getting the accuracy of 100%. So let's assume whatever the training that I have done is at a ideal place, and this is the ideal model that I have got, and assuming that the data set is working really well and my machine learning model is performing at the peak level, and I'm assuming that I'm satisfied with my model performance. So I'm very happy. I've shown this to my colleagues and I've shown this to my managers and I've shown this to my leadership, and they're happy with the machine learning model performance on the new data set. Now what I want to do is I want to ensure that this model that I have got, so this model should be used future. That means I want to use this model for future purpose. So let's go ahead and do that. So I have decided that I want to use this train model, and using this train model, I want to deploy it as an application. Now that's where the challenge lies. See, I've got my model with me. The model is working perfectly in my notebook. Now, how do we take the model out of this notebook and implement it somewhere in the application? So how can I do that? Now, that's the question that we have got. So as a practice, what we do is, so here, as part of this activity, we are going to store the trained model in an external file. Now, once we save the trained model in an external file, we will use that file in generating the prediction in my overall application. So let's go ahead and do that activity. Now, in order to dump the model to an external file, I'm going to make use of a library that's called as a joblib library. So I'm going to say from joblib, I'm going to import dump. So dump is a function that we use it in order to dump a model instance or any variable into an external file. So apart from this joblib, we have the other alternatives as well. So for the demonstration purpose, I'm using the joblib. If you want, you can also use the pickling or any other available library that you would prefer in order to save the data to an external file. So I'm going to demonstrate as how we can dump the data to an external file, and I'm going to show you as how we can load as well. So for demonstrating the same, I'm importing both dump as well as load function. So I'm going to say dump. Okay, now what is it that I want to dump? I want to dump the model. I'll say tree, that's a variable name, and I want to save as my final model dot the extension. I can mention any extension because it will be saved in a binary format. It does not have any preference over there. For the demonstration purpose, I'll say final underscore model dot joblib. Okay, this is how I'll be saving the file. Now, apart from this model, I also have to ensure that I'm saving the object of standard scalar. If you remember, we have trained our standard scalar. That means we have learned this from the standard scalar. And if you look into this standard scalar, and if I just show you, okay, if I just show you the output, okay, if you look into the mean and scale, that is my standard deviation, see, you can actually see the mean and the variance that I have captured from the data set. So using this mean and variance or the standard deviation, so we have actually performed the transformation. So I want to save it into a file so that when I'm working at a future time, so I'll be able to use the same mean and standard deviation which I have learned from my given data set. So I'm going to dump the same. I'll say ss, that's a variable, and I want to save it as standard underscore scalar dot joblib, and I'm going to execute this. So once I've done the execution, so if I open that folder, okay, so if I open that folder of my end-to-end machine learning deployment folder, see, I can see two files are present. One is final model.joblib and the standard scalar.joblib. So the two files that I have saved is present locally right now. So now I can use these files and I can give it to the front-end developer and give them an instruction that how to load this file and how to perform the transformation. That's all. And using the same, we'll be able to generate the prediction or the output. All right, folks. So I'll stop the video over here. So as part of this video, what we have done is We have loaded the data set, we have performed the training, and we have saved the trained model in an external file. Now, in the next video, we will learn as how do we use this trained model into an application. So I hope you guys are as excited as I am. So I look forward to seeing you in the next video. So thank you so much, everyone. If you have got any questions, please let me know in the comment section and feel free to reach me on LinkedIn. And I look forward to seeing you next time.